Hello everybody, welcome to your 10-1 lesson on arcs and sectors. Our learning target for this lesson, we are going to find arc length and sector area of a circle and use them to solve problems. We will be able to calculate the length of an arc when the central angle is given in degrees or radians, that's new for us. And we also will calculate the area of sectors and segments of circles. All right, so clearly we have some vocab to put in. So let's jump right in. Some review of what you know when you are talking about the center of a circle. Here's a circle. I'm going to put a point at the center. I'll call that point P. We would call this circle P. That's how we can name circles based off of their center point. So all circles have a center. Now a radius, here's another circle. Radius is going to be from the center, so let's say that's P, to the edge of the circle, Q. So the radius of this circle is segment PQ. And if I were to just kind of write that out in words, it's from the center to the edge. Well, that is not how you spell edge. There you go. All right, diameter. Here's a circle. A diameter is going to go through the center of the circle, and it's going to connect one edge or one end of the circle to the other end. So if this is point R, let's say we still have circle P, and this is Q. Our diameter is segment PQ, and in words, that would be the segment connecting 2 points on the circle and it passes through the center. Did not give us a lot of space for that definition. All right, well, what's a chord? This actually might be new for you guys. So you have a circle. Let's say we know that our center is P. A chord could look like this. And let's say this is point T, this is point S. So the chord is segment TS. It's essentially just a segment connecting any 2 points on the circle. So, do you guys think that the diameter is a chord? Is it a segment connecting 2 points on the circle? It is, but if your chord is passing through the center, then we get more specific with the name and now we call it a diameter. But a chord would be any segment connecting 2 points on the circle. All right, central angle. So a central angle is going to, let's draw this out. Let's say we have center A and I draw out to, let's say, point P and out here to B. It's an angle formed by 2 radii. So radius is 1, radii is 2, plural, with the vertex at the center of the circle. That's why we call it a central angle. So in this case, our central angle is angle PAB. The vertex is at the center of the circle. All right, an intercepted arc so here's another circle. If we have, let's say, centers. A again will connect to point B, connect to point P and B. So an intercepted arc is going to be this right here. This is called an arc. If we put that into words, it's the part of a circle that lies between two segments. In this example, those two segments are the radii. That intersect the circle. So how we would write this, that is arc PB. So we would write PB. I don't want to write it there. We would write PB. And instead of putting a segment line above it, this is an arc. So we're going to put a little arc symbol above it. So that is arc PB. And it is the part of the circle that basically connects P to B right there. One thing to note, the central angle and its intercepted arc have equal measures. So in this picture, this is a central angle. So this angle measure right here would have the same measure as the arc. All right, so a circle measure is, so the total measure of a circle is 360 degrees. And the total arc measure of a circle is 360 degrees. So if you think about a circle, I'll just look at this one up here. The measure of the circle, we know we can go around 360 degrees here at the vertex. The arc measure going around the circle is 360 degrees as well. All right, I'm going to jump down to semicircle. Semicircle is half of the circle. It is equal to 180 degrees. What that's going to look like, here's a circle. Semicircle will go through the center, basically the diameter. So wherever we might draw in the diameter, let's say this is D, this is E. So the semicircle is arc DE. I could say this arc right here, or I could say that arc right there. All right, so a minor arc is an arc on a circle that is smaller than a semicircle. Remember, a semicircle is 180 degrees, so a minor arc will be less than 180 degrees. We do need to take note that we use two letters to name a minor arc. So what that looks like in a picture, let's put a circle up here. So it's kind of smaller, but I think we can get this to work. Let's say that this is point P, this is point Q. The arc connecting P to Q right here, that's an example of a minor arc. I can clearly see it's less than half of the circle, the semicircle, so it would be considered a minor arc, and I only need to use 2 points to name that. If I were to say P to Q, here's P, I would go the shortest or the quickest pathway to get to Q versus going around the long way, we go the short way to the Q. Now, a major arc is going to be an arc that is larger than a semicircle. On this one, we have to use 3 letters to name it. So again, let's just throw a circle on here. Appreciate you guys sticking out this longer intro video. It's a lot of vocab. Okay, so let's say we have point A, point B, point C. Now, if I said arc AC, I would go A to C, the quickest pathway to get there, right? That's a minor arc. What if I want the arc going the other way? So if I need it to go the other way, I have to use 3 letters, which means I would need a point between A and C that would create this major arc. So I would call that arc, let me outline it in red. The arc from here all the way around to here would be arc A, B, C. We use 3 letters to name that.